Hi, and welcome to the recording of A Bit of Life. This project was created and implemented by Ryan Morris Scott, Dami Lola John, and myself, Aiden Cottrell. So here's our first creators page. This is for team info. Our first member is Ryan Morris Scott. He was the front end engineer. And there's his GitHub link. The Scrum reflection just says one of the most impactful aspects of using Scrum was the focus on continuous improvement through regular reflection. Each sprint retrospective gave us a dedicated space to discuss what went well, what could be improved, and what actions to take moving forward. For instance, after our first sprint, we realized that our initial estimates for the complexity of the admin panel were too optimistic, and so by reflecting on this during the retrospective, we adjusted our estimation techniques and improved our planning for the subsequent sprints. And these sessions were not just about the process, they also gave us a chance to reflect on our teamwork, how we were communicating and growing with each other. So over time, this practice of structured reflection helped us to refine our workflow, enhance our technical skills, and strengthen our collaboration. The Scrum methodology's emphasis on learning from experience was key to our success and personal development throughout this project. Okay, and so then we have Dami Lola Johns. He was our back-end engineer, and then there's his GitHub link. So his reflection says that Scrum's framework fostered a high level of collaboration and transparency within our team. The daily stand-ups and sprint planning meetings created a routine where everyone could share updates, voice concerns, and offer suggestions. This open communication helped prevent misunderstandings and ensured that everyone had a clear understanding of their responsibilities and the project status at all times. For example, when working on the database integration for user stats and session tracking, we encountered some technical hurdles. Because of Scrum's transparent environment, we were able to quickly bring these issues to the group, brainstorm solutions, and divide their work efficiently. The structure also encouraged us to self-organize and take ownership of our own tasks, which boosted morale and made the project feel like a true team effort. Overall, Scrum's collaborative approach was instrumental in building trust and accountability among teammates. And then we have mine. This is Aiden Cottrell. I was the project leader and full stack engineer, so I worked on both the front end and the back end. In my reflection, I said that working with the Scrum methodology on our Conway's Game of Life project highlighted the power of iterative development and adaptability. And by breaking the project into manageable sprints, we were able to focus on delivering small functional increments, such as the user authentication in Milestone 2, the interactive grid and player dashboard in Milestone 3, and the admin dashboard in Milestone 4, along with Milestone 5 just being having everything set up and polished rather than just trying to build everything at once. This approach allowed us to regularly review our progress during sprint reviews and retrospectives, making it much easier to identify what was working and what needed improvement. When we encountered unexpected challenges like integrating real-time grid updates with React, Scrum's emphasis on adaptation meant we could quickly reprioritize tasks and adjust our backlog, which I have pictures of later in the PowerPoint presentation, ensuring we stayed aligned with our project goals and deadlines. The regular feedback loops built into Scrum not only improved our product, but also increased our confidence as a team in tackling complex problems. And so here's the creators page, but more for the app info. So our project name was Bit of Life because you can see each grid as a bit and the game of life. So it's a clever little play on words, if you want to call it clever. And then we have our test cases. We have game grid, so making sure that our cell toggle was working, that you could resize the grid, that you could properly load the patterns, that the generation counter was working, that the start and stop button worked, the next generation button would iterate, and that the reset button would properly work. We also tested responsive design, making sure that it worked on both mobile view and desktop view. And then we have our user authentication, so we wanted to make sure that registration went through proper. So we could test that by registering a new user with valid credentials. We also tested for duplicate registration, so attempting to register with an email or username that already exists. and this would prompt you an error message. And then we have our login, which would just be logging in with already registered credentials. The user would then be redirected to the appropriate dashboard, whether they are a player or an admin. An invalid login, which would be testing a login with incorrect credentials. This would display an error message instead of allowing you to log in. Session management, so just accessing a protected page without logging in. The user would be redirected to the login page in this case, and then log out. So the user is able to log out from the application, meaning that the session is destroyed and the user is redirected back to the login page. And then we have our admin dashboard, so we wanted admins to actually be able to view the analytics. So this means that they would log in as an actual admin and be able to view that on their dashboard. They could suspend users by entering their IDs, and they could also view charts for the top users. And we did the charts using Google integration, Google Charts. So then we have our database integration, which was just verifying that the users were being added to the table, game sessions were being tracked, and that patterns were also being saved. We have our gameplay test cases, so just making sure that that Conway's rules are actually being played out within the application. Edge cases, so pitting live cells at the edges of the grids and watching them go through their generations. And so the edges, they should be treated as being surrounded by empty cells on whichever side the edge is facing, if that makes sense. So if they have available cells to their left, but they're on the right edge, so to the right of them there are no cells, then those would be treated as no cells and align with the rules. And then we have our oscillators and still life. And this is just loading the two patterns we previously already saw and just making sure they work, which we saw that they did. We'll see that they do in the demo. My apologies for getting ahead of myself. And then we have the performance test cases, so just making sure that it still runs well on a larger grid and through a high number of generations. And then, so now we have some code snippets. So here is the implementation of our Game of Life rules. So as you can see, it's within a constant next generation function. It uses callback, it creates a new grid, which it maps to the rows. And then as you can see, it's counting the neighbors, and then it's calculating if it's underpopulation or overcrowding or reproduction, or if it just needs to stay the same. And then we see it sets the grid and sets the new generation. So then we can go to the next one. So here's the code snippets for our dynamic grid creation. So here we have the empty grid that's created, and it just takes in two inputs, rows and columns, and then it returns from the array the length of the rows and the length of the columns. And so here, as you can see on click, you can toggle the state, which my apologies for leaving off some, but it's just column index at the end instead of row index here for both. And then that's what's toggling that's also what's toggling the state of the cell, so if it's alive or dead, which triggers a color change. And then we have our predefined patterns. So here's the block, the blinker, the beehive, and the oscillator. And so here's the function to load them. So it's a const function, we load the pattern name, and then based off the pattern name, it takes in these values, and then it starts at the center using this floor function to make sure it's at the true center, and then it just places them, and then starts the generation over, and yep, we move on to our analytics query. So this is just some PHP MySQLi code snippets. So this is for fetching the analytics data if you are on the admin dashboard. So as you can see, we have the users count, which just finds the count of users, games played, which just finds the count of game sessions for a user, and then top users. So as you can see here, we are selecting their username, we are counting the number of game sessions per their ID as games played, and that's what we're just renaming it as. And then we're going through the users, and we're going to do a join here on the game sessions that have the same users. So as you can see here, and then we're going to group it by username, and then order it by games played. So all this code is basically just allowing you to see users who have played the most games. And then we go to next. So this is the Google Charts integration that we use for our data visualization. We have the import for the JavaScript here. This is just to load it. And then this is the thing, this is the script for our integration of the Google Charts. So I can see we have it here, the loading of it with the packages, and then just setting it on a load callback for the functions. And then here's the function that's doing it. And it's just taking the data from the table and applying it. And we also have one for a pie chart. Well, there, okay. And then here's our database schema. So this is just one database, the users one specifically. We have the 3 other ones, but this is just what's in the snippet. So this is what's creating the database. This is just the base of the SQL that needs to go into creating it. And so we select onto our database, and then we create table if it doesn't already exist, because you don't want to have multiple tables with the same name. It's going to throw you a lot of errors. So we have our users, and then we assign an ID to it so that it's easily indexable or accessible. And so we have it auto increment for each new user, and this is the primary key because since each new user is getting a unique ID, it can always be used to identify said user. It's also just an integer variable because it's just a number for the ID. And so the username, it can be a variable size string of up to 50 characters, and it has to be unique and it cannot be empty. That's what the not null and unique mean. Same with the email, but it can be up to 100 characters, and it can't be just empty because that's not acceptable, and it has to be unique. So if another user already has it, then you have to take it up with that user or figure out what went wrong somewhere in the process. Here's the password. It does not have to be unique since multiple accounts can technically share a password. It's not truly sharing, it's just having the same one, but it causes no conflicts. The password ends up becoming hashed anyway. And then then we have the enumeration of the role, if they can either be a player or an admin, and by default it is player. Right now the only way to change it to admin is by actually going into the database and manually changing it. This is just to ensure the security of the admin role. And then we have our timestamp, just when it's created. And then, we just have our little messages for if there's an error or if it was successfully created. So then we have our registration, which requires the database to use, which just means that it's going to go through the database to find the users. So here we have our post method, and it's just going to take the username, email, and password, and then give the default player role. And then it's just going to do some authentication to make sure that the password is at least 6 characters long and that the format of the email is correct. And then it's going to hash the password right here. And then it's going to insert this into the database for the registration because you're adding more users. So now we have the login, which is also going to take the database, and then it's also going to start our session, so that starts being monitored. And then it's going to take your email and password and make sure that that lines up with the ones found in or inserted from registration now in our database. So we have our statements here. So this is just, it's saying you're inputting whenever you log in your email and password, and then it's going through the database and selecting to where that is, and then it's just making sure that that is verified. And so now we have our screenshots of collaboration, our dialogue. So we have our project that we made on GitHub to help us monitor. It was our backlog to help us monitor our progress. So obviously milestone 1 was getting the GitHub and everything set up, so there was no need to pit that. But as you can see, our 4 milestones are all over here. Milestone 2 through 5, they started off in our to-do, we worked on them, and they went in progress, and now we have them all finished as the project is done. And so as you can see, we took advantage of the markdown present on GitHub's pages and used it to make a task list of what needed to be done in each milestone. So milestone 2 was user registration, login, and roles. And you have, as here, we have everything marked off. And then player dashboard and game features in milestone 3, we have that. And then milestone 4 and 5, we have the admin dashboard and analytics. And the milestone 5, we have final polish, testing, and the presentation. So then here is our walkthrough of functionality. Welcome to the demo running of the Bit of Life, which is just Conway's Game of Life. So as you can see here, we have our basic grid, and then there's not too much to take in here. There's just a generation counter up top, your grid system, which is interactive. It updates based on the grid you click on. It becomes colored to signify that it's alive, and when you click it again, it is uncolored to signify that it is dead. So here we have 2 still life patterns, block, beehive. If we start, they don't move. Test it out with block. Start it. It's still not moving. And then we also have a manual next generation button and a reset button, which I'll go ahead and hit reset now. The grid is reset and the generation is back down to 0. So now we'll show off our oscillators. So we have blinker, start it, and we'll stop and we'll show off the next generation button. We'll click it a couple times. And as you can see, the generation goes up and the blinker is blinking. So then we'll show off Toad. This is Toad, doing its little oscillation still. And then, so now we'll just make our own. We'll reset the board, and then we'll just do something, have a bunch of random stuff going on, and start it. And that is pretty much it. Okay. Welcome to... sorry. And that is it for this presentation as well. Thank you.